In this problem, we are simplifying some complex number expressions, and so we're going to use the imaginary unit and some of our knowledge about that. In the first example on the left, we have a bunch of distributed properties occurring and going on here, so let's try this out step by step. First of all, if we distribute the 2i out, we're going to have 2i times negative 1, which is negative 2i. Then we'll have 2i times 6i, so I have minus a 12i squared. Just for fun, because it doesn't change anything but helps me to group, I'm going to group those at the beginning there, so I'm putting parentheses around it. Although they're extraneous, it doesn't really do anything. But it helps me to train myself into remembering that on the second part here, due to the big minus sign, I do need to group these last two parts. 2 plus I times 2 minus I is that's a fortunate difference of squares. So down here I'll go 2 squared, 4, minus I squared. So that's the difference of squares formula helping us out a little bit. Okay, so now in the next step of simplification, we're going to take any I squareds we see and convert those into negative ones, because I squared is negative 1 by definition. So now we'll have a negative 2i. The I squared is a negative 1, and 12 times negative 1 is negative 12. So if we subtract a negative 12, we're going to be adding a 12. Minus, and over here we're going to have a 4. I squared is negative 1, so we'll have 4 minus negative 1, or in other words 4 plus 1. So now negative 2i plus 12 minus 4 plus 1, of course, is 5. So now if we're going to write this in standard form, we simply have 12 minus 5, which is 7. We usually write that one first, and then we have this minus 2i that we put over here. So the final answer is 7 minus 2i. Now, over on the right, we have a radical in the denominator, right? Because I is the square root of negative 1. So we are going to need to simplify this by multiplying top and bottom by the conjugate of 3 plus 4i, which is, of course, 3 minus 4i. So now, in the numerator, if we distribute the 5 against 3 minus 4i, 5 times 3 is 15, minus 5 times 4 is 20, so in the numerator we're getting a 20 times I, and then the conjugate multiplication on the bottom will yield an a squared minus b squared, right, because it's a difference of squares when we multiply by the conjugate. So 3 times 3 is, of course, 9, minus 4i times 4i is 16i squared. So yet again, I squared is our negative 1, so we're going to replace that with negative 1. So in the numerator we have 15 minus 20i, and in the bottom denominator we're going to have 9 minus negative 16, because 16 times negative 1 is negative 16, so we'll get 9 plus 16 effectively. Okay, so what can we do now? It looks like that's 15 minus 20i over 9 plus 16 is 25. And so as a final answer in standard form, we like to write this as 3/5, which is 15 over 25, minus 4/5 I, because 20 over 25 is 4/5. And so that's our final answer.